Well, good afternoon, everybody. The day before Halloween. So we have a guest coming to talk with us today, Dr. Hugh Broom. Hugh has been with us for quite some time now as a professor, and he's going to talk to you a little bit about stuff in his world. So if you want to come up and so that people can hear on the microphone clearly. I'll pass out attendance cards.
Good afternoon. How are we doing? We're good? We're at that stressful part of the semester, yeah? So Dr. Masterson asked me to come speak, and he said I could talk about anything I wanted to talk about,
Yeah, I did say that. That's right.
as long as I had one slide and talked for 10 minutes. So how many of you know who I am? How many of you seen me? I know a few of you. I've seen a few of you around. When I'm done, I want to know all your names, but let me get my 10 minutes out of the way first. Got it? First of all, I haven't got to meet each of you, so welcome to USM. Welcome to chemistry. You are part of a pretty long line of people who have earned chemistry degrees here at the institution starting back in the 1940s. But today, I didn't really want to talk to you about what it meant to be a chemist. I wanted to talk about what it meant to be a scientist. Because many of you may go on to awesome chemistry careers. Some of you may consider careers in medicine or in other aspects that apply to chemistry. Some folks go into law school following chemistry. Some people go into a variety of other disciplines that are fundamentally rooted in chemistry. But a scientist is not just a chemist. A scientist is someone who's observant. And by default, a chemist is a scientist. But we, and I mean collectively all of us, we observe the world around us. And not only are we looking for things in the world around us, we have this natural curiosity about us that really causes us to question that world. And to wonder what might happen if we made a small change in that world. And by wondering, what part of the scientific method is that? If we ponder, if I drop Dr. Masterson's bag, I
We'd be in trouble.
would be in trouble. Yes, okay. That's to make a hypothesis. Like what do we hypothesize will happen if I drop his bag? Besides, I'll get in trouble. He'll block my emails. We hypothesize it'll do what? It'll fall, right? So that now you're taking knowledge that you already know and applying it to a new situation. You know it'll fall because there is this law called what? Gravity, yes, absolutely. And then as a scientist, we sort of experiment. We're interested in what does that do? How can we change the world around us by changing small things, looking for unique results? But it's also important that as scientists that we communicate our findings. Imagine a world in which someone had discovered electricity but had never communicated that. None of this would be possible. None of it. So it's important as a scientist that we do that. And through communication, we advance knowledge. We look at that knowledge around us and we're like, what other knowledge can be added to the body that we already know? That's a pretty heavy weight, don't you think? But you all are going to be amazing at it, I promise. So by advancing that knowledge, we often are solving problems. Many of us saw that happen during the COVID-19 pandemic. What are some problems that you saw being solved? Anybody? Yes.
Creating vaccines.
Creating vaccines. Yes, absolutely. the vaccines were messenger RNA vaccines. Some of them were. That vaccine technology was probably about 20 years old, but had never been applied to SARS-CoV-2 or COVID-19. Yeah. And by creating those vaccines, we improved quality of lives for the people around us. And whether, as a chemist, we improve quality of lives, but sometimes as chemists, we make the world a worse place. Have you heard of PFAS? So these are polyfluorinated compounds, which means they have lots of what element on them? Fluorine, yes. So these are pretty awesome compounds in that they are typically put on clothing or a variety of other things because what do you think the polyfluorinated compound does? It prevents your clothing from doing what? If I spill something on my clothing, it helps prevent stains, right? It helps prevent other chemicals from reacting with the cotton and dye in your clothing. So chemists developed PFAS. They were like the wonder molecule. But now they're everywhere. And we are finding out that they're not as inert as we thought. They react with various organs or inside various organs in your body, like your liver or your thyroid. And so now we're having to actually clean up the awesome thing that we did as chemists. And that requires critical thinking. How do you clean up a molecule that is not reactive? By default, it's designed to be inert, not reactive, sort of in the background. But now you have to not only clean it up, but you have to find it, you have to do that. And PFAS are everywhere. You probably have consumed PFAS today in your water. A little bit scary, yeah? So scientists, when we know knowledge and we advance knowledge, we also act as advocates. And we advocate for better laws, better policy, and better things around us. And that requires us to be able to clearly communicate the complex science to people who are not scientists, which is a wonderful skill. I know that you've gone through the scientific method a lot. You've talked a little bit about chemical history, and you've seen how the thought process of science has evolved over time. And it's continually evolving today. And that informs new laws and new policy. But as we do that, we're also required to be ethical humans. I could say that I've just discovered the cure for cancer. That would be pretty awesome, right? Don't you think I'd be pretty rich in about 3 or 4 days? Yeah, some pharmaceutical company would want to buy the cure. But if it doesn't work, then maybe not. There's some really awesome, well, not awesome, let me just take that back. There's some really interesting ways that scientists have been unethical and have been sort of corrected by their peers. Does anyone have an example of sort of science that has been published but then withdrawn once it was found out that perhaps the results were either fabricated or altered in some way?
We had some examples out of chemical and engineering news earlier, right?
Polymers. Okay. The most famous one that I was thinking about was vaccines cause autism, right? That's an interesting paper that has been withdrawn, right? And so, I guess to conclude, what I wanted you to take away was, as a teaching track faculty, I do research, but I also am interested in talking about who we are as scientists. I see us really as knowledge expanders. So I was talking about that advancing knowledge, solving problems, improving the quality of life. I see us as problem solvers. We're here to figure out how to get rid of those PFAS. But I also see my role and Dr. Masterson's role in not only doing that, but inspiring future scientists, just like you. Thank you. Do y'all have questions?
Questions for Dr. Broom?
That was heavy. I just
So
gave
Dr.
a test.
Broom, do you consider working with any students on research projects? Maybe you could comment a little bit on that.
I'm currently working with one student on an honors thesis. We're looking at how chemistry experience affects attitude. So, you all are chemists, but maybe you've taken a chemistry class or had a friend that was just like, why are you chemistry? Yeah. I could never do that. I hate chemistry, or I'm not good at chemistry. Y'all heard of those? Yeah. Yeah. So that attitude is quite pervasive and exists quite a bit. And so we're interested in how does experience, both good experience and bad experience, sort of affect your attitude. Because it turns out your attitude is pretty powerful in affecting how you learn. Have you ever been in a class where you're like, I did not care about this class? Everybody should raise their hand.
Not this one.
Not this. You've been in that class, right? You're like, I do not care. Do you try as hard in that class? Probably not. So we know that attitude impacts learning, and I'm curious as sort of the interface of that, especially for chemistry, because there's a lot of, as the literature calls it, chemophobia out there.
Is anybody maybe interested in that type, not necessarily maybe that exact research, but that type of, have that kind of curiosity where you're interested in the interface of people and their attitudes and science in general?
Let me go over here next to the microphone so folks can hear.
Anybody at all interested in that?
I was interested in it for like a while last semester, especially, but not just for chemistry, just STEM in general, because I've noticed a lot of people think that it is a difficult field, but I just feel like what would happen if people thought it was like a more easier or like average type degree.
So let me ask you, let me follow up on that a little bit. What makes you think, or why do you think people find chemistry difficult?
Partly math.
Partly math? Okay.
Partly
The language is different.
The language.
Oh, yeah, definitely.
media
Mhm.
and how it's presented.
The media and how it's presented.
Well, I think it really comes down to like the beginner education that they got, because if they didn't get a great foundation within high school or something, and then transition into college, it is a lot that's coming at them, which can make them unsure about the subject.
Yeah.
Okay. Anything else? Yeah.
I think people tend to get in their heads, because I noticed that when I was taking calculus, my AP Calc in high school, a lot of it was people just trying to think too much when you just needed to do it.
Mm.
Okay.
Interesting aspect.
They don't need it in everyday life.
They don't need it in everyday life. You
So,
don't believe that? Now, obviously, you are here for a reason, right? You're here for a reason, so obviously you don't believe it. But there's a lot of people out there. And I was one of these. Dr. Broom may have been one of these. I grew up in a small town on a farm. I never saw a chemist in my life until I got to college. What interested me about chemistry was the 1970s, or the later 1970s. Every show you had on at that time was about science and technology and this, that, and the other. These are things that you all probably have not been exposed to, but the $6 Million Man, all that cool stuff that you can do with science. I was seeing it. You probably don't see that as much today. You probably see the Kardashians and the things that are going on there.
but I think there are still creators out there that are pushing science. Do y'all follow any on TikTok? I follow Chemical Kim. Do y'all follow Chemical Kim? She's a professor in Florida. She does really awesome demonstrations. And Steve Spangler does some awesome stuff too on YouTube.
Nile Red,
Yeah,
yeah.
Nile Red.
Veritasium,
Yeah.
Veritasium is awesome.
yeah.
The YouTube videos are long, but they're really good. My favorite one is the most radioactive place on Earth.
Yeah, very nice.
He has a PhD in physics education from I think it's New South Wales or Monash. It's an Australian institution.
I don't know.
Yeah.
Let me ask one other question. So many of you in previous conversations we've had, many of you are not choosing to become a professional chemist like Dr. Broom or myself, and that's perfectly fine. But you will be a science advocate if you become a doctor, a lawyer, and whatever you end up doing, even if it's a non-traditional degree, right? You're going to take this and you're going to advocate for the science and the scientific method, right? And so hopefully, regardless of your career path, you will be able to communicate the value of science to the community. It's very important that we have that ability to do, as Dr. Broom had alluded to or mentioned.
The most telling example I have of that, over the summer, my mom had some very serious health implications. And I got to watch her physicians struggle. My mom did not go to college. Much like Dr. Masterson, I grew up on a small farm and also saw a chemist for the first time in college. But you chose chemistry because of sort of your exposure to science. I chose chemistry because I thought it was awesome and it sort of explained how the world around me worked. And so I like that. And sometimes I find in chemistry education, we don't do enough of connecting it to everyday life, right? We teach it and we're worried about those concepts like, do you understand the size of this atom and how it reacts, or the structure and the property? But I watched my mom's physicians struggle to communicate their decisions to my mom. And it was really good that she had me, who could like act as an advocate for her, a go-between, to say, okay, you're getting this medicine because this is what your labs say, and your labs indicate that. But then I also would question the surgeon and be like, all right, so I'm noticing this number is low. What is typical? What do you do? How do you do that? And so it's really hard to communicate science, because we're talking about really complex subjects. It's not like we can just pull an atom off this table and be like, here it is. I mean, you're looking at trillions of atoms right now. And so it is hard. And it's hard to understand that science is usually not a yes, no, or correct or incorrect. It's often, this is what the evidence or the results say, this is what I know. If I put them both together, I think this is the right path forward. But it might not be. It's sort of trial and error.
So one of the things next week that we'll be talking about are non-traditional things that you can do with a chemistry or biochemistry degree, right? Many of you are thinking about medical school, many of you are thinking about some type of professional school, some of you are thinking about graduate school, some of you are thinking about getting a job. And that's all great. We want you to have whatever it is that you want out of life, and we think chemistry can certainly help provide that for you. But I want to spend some time next week having us talk about non-traditional things that you can do. And what do I mean by non-traditional? Anybody want to take a guess? Patent lawyer?
Yeah.
Okay, you might not think, hey, I want to go to law school, maybe I need to be a chemistry major, right? You might not think that.
Do you know who Angela Merkel is?
German chancellor.
She was the German chancellor. She has a PhD in physical chemistry. The Pope has a master's in chemistry.
I'm not saying you're all going to go out and be Chancellor of Germany, right? But there are a number of career paths that a chemistry degree can feed quite well. And I would say the career path that Dr. Broom has taken has really only been popularized for the last 15 or 20 years.
Yeah.
I mean, to have a teaching track and teaching pedagogy research areas up until, again, the last 15 or so years was not really heard of much at many institutions.
Well, we didn't even start thinking about how do we teach chemistry until, as a research area, until the 1970s, with the advent of chemical education research. So it is thinking about how we teach. Chemistry is fairly new in the span of chemical history, maybe just the last 50-ish years or so, that we started to really think about how do we teach this, how are students learning at, are we actually hurting chemistry by the way we're teaching? Sometimes we actually propagate misconceptions through teaching.
So if y'all are all interested in that kind of work, I will mention a couple of things. One, obviously Dr. Broom is the local expert on that. And so if you're interested in talking further about that, I would encourage you to meet with him. Also, I would say that we do have a degree track or a major in chemistry education, that if you at some point think, you know what, maybe I'd really like to teach. I really like chemistry, but I don't see myself being at the bench. I don't see myself going to medical school. I really don't want to work in industry. It's a viable option, and it can be a first option. And so if that's something that might be of interest to you, I would encourage you to talk to Dr. Broom about that, but also Miss Megan Fortenberry. Many of you probably have Miss Fortenberry right now. She is a chemical education expert as well. So that's the path that she chose. So those two individuals in our department would be the best to talk to. I could talk with you a little bit about it, but believe it or not, I'm not qualified to teach at the high school. So but anyway, thank you, Dr. Broom, for coming by.
Thank you all.
Appreciate it. Let's give it another round of applause.
So, can I ask all your names quickly? I know some of your names, we'll just go around the room. Is that cool? So
That's
your
fine.
names. I know you.
I'm Smiley.
I'm Chris.
Chris.
Mackenzie. Taylor.
Sunday.
Morgan. Taylor. Michelle.
Will.
Audrey. Kizzy.
Alright, so I need some of your names, but it's really good to put a name to a face. It's really nice to meet you all. If you need anything, you can of course email me or email Dr. Masterson and he'll put you in contact with me.
Thanks for coming by, Hugh.
Thank you
Appreciate
for
it.
having me. Thank you all.
Thank you.
All right, folks. We did not have a whole lot to technically go through today. I'm not going to show you the former Golden Eagle video today. That'll be some questions for the end of for Friday. But I did want to talk about this idea of chirality before we jump into talking about CVs and resumes. We're going to talk a little bit about that. I hoped to do that last week, but obviously, had a lot of good questions for our people here, and so I let that go a little longer than I had originally planned. So what is this concept of chirality? Why is it important? It's not something you've learned in Gen Chem yet. For those of you in organic, you might have learned it by now.
Yeah. I just know like it's when two molecules are basically mirror images of each other, right?
Sort of. You're close. You're really close. Everything has a mirror image.
Mm-hmm.
Right? If you could put anything up in front of a mirror and the image is staring back at you, right? But not everything is chiral. So you're partly right.
4 different types of groups.
Okay, now you're getting into the specifics. I'm trying to keep it very broad at this point. Very broad at this point, because there's a lot of chirality in nature that has nothing to do with 4 different groups. That's a result. You're not wrong. Okay? Just a little ahead of your time there.
It's like when everything like has like a center, so like a symmetrical sun, something like that.
Okay, symmetry is coming into it. I'm hearing symmetry. What else?
It has to do with how the molecule like reflects light or rotates light.
It does have something to do with that. If and only if something else is true. But you're on the right track.
Well, if it has 4 different molecules attached to the carbon.
Okay, if it has 4 different atoms attached, yeah, we can get into that. All right? But I'm talking about in general. You're getting to the specifics. You're not wrong. Right? Well, let's think about what do you have right now that is chiral? Pardon?
Person?
We do. You're not wrong. I'm thinking bigger than that. Our hands. Chirality actually means handedness. Okay? What do I know about my right hand? I've got a palm, I've got a thumb, and 4 fingers. What do I know about my left hand? I've got a palm, a thumb, and 4 fingers. It sounds the same, does it not? Are they the same? They are not. How are they related to one another?
They are not superimposable.
Yeah, so first of all, they're mirror images. Notice if I hold up my right hand, the left hand like this. Notice the right hand, the left hand is its mirror image. It's the reflection. Go home tonight and go to your bathroom where you got a mirror or whatever, and hold up your right hand, you'll see your left hand. Hold up your left hand, you'll see your right hand. Is the reflection. These are mirror images of one another. Right? You all buy that? This is what it looks like when you hold your right hand up against the mirror. Right? That's exactly what it looks like. You can do that with anything, but I wouldn't call it chiral. What else has to be there? It's a mirror image, but I can't superimpose one on the other. Notice when I take my right hand and try to lay it down over my left hand, things don't line up. That's not true of all things. If I take my socks, assuming my socks don't have the toes carved in them, okay? And I hold my sock up, I get the other sock, but I can lay the socks on top of one another and can't distinguish one from the other. I don't worry about a left-handed sock or a right-handed sock. But do I worry about a right-handed glove and a left-handed glove?
Yes.
Have you ever tried to put a right hand in a left-handed glove? Does it work? Doesn't work at all, does it? Okay. Now, somebody said proteins. I think it was you. You said proteins. They are chiral. Okay? And just like the hand and the glove, right? You got to have a right hand and a right glove and a left hand and a left glove. Proteins have a handedness to them. They can either be left-handed or right-handed. And so it matters in biological systems when we take drugs that are chiral. One drug may interact with that protein differently than the other, what we call enantiomer. Don't worry about that terminology. We're learning organic. Okay? But the right-handed molecule may interact with that protein differently than the left-handed molecule. And if you all were going to take organic chemistry from me, I would pass out a model kit to all of you. I didn't have my model kit, so I couldn't bring them today. And we would all build a chiral molecule, this idea of a carbon atom with 4 different things attached to it. Turns out that's chiral. And as you can probably guess, I'm pretty passionate about this because this is my research. I do a lot of chiral work, okay? So this is something that I really find fascinating. And we would sit there and imagine it's a carbon atom, it's kind of shaped like a tetrahedron, and we have 4 different colored balls we're going to put around it. And I said, just at random, put those 4 colored balls on there. And then I would ask, did we all make the same thing? And you all would say, of course we made the same thing. We had a carbon atom of the same 4 colors. They're all connected the same. And I would say, you're right and wrong at the same time. And I would take my molecule, and I would come over and I would grab her molecule, and I'd say, oh, look, everything lines up. We both made the right-handed molecule. And then I would go over here and I'd say, let me look at yours. And I'd go, oh, look, it doesn't line up. And I'd go through the entire class, if the class was big enough, and we'd find that it would be almost exactly a 50-50 mixture. We call that a racemic. We call that a racemic mixture. And it turns out that making racemic mixtures, or equal amounts of the right-handed version and the left-handed version, is very easy to do. But it had problems in medicine. Can anybody think of an example? Anybody know of an example in medicine where this idea of chirality turned out to be detrimental?
I don't know the name of the drug, but it was an anti-nausea drug for pregnant women, and the S rotation of the compound caused abnormalities in the
That's
progression of the baby.
Yeah, it was used the same.
That was-
Yeah, it's called thalidomide,
Oh, that's
right? It's called thalidomide. Tonight, go look up thalidomide and look up. I'll give it to you in the assignment. Y'all, it'll be a good assignment. I'll make y'all go look up thalidomide and talk a little bit about it. That's what we'll do. And it turns out that one hand of it, if you will, let's say it's the left hand, I don't remember which one, treated this nausea problem. But the other hand, as he was talking about, caused massive birth defects, grotesque birth defects. It was terrible. Okay? And so you couldn't give that drug as a racemate, right? And there's other complications that come in there with it that we don't need to get into today. But today, almost all drugs that you take, almost all drugs that you take, are what we call enantiomerically pure or chirally pure, that meaning they're only one hand. Because the Food and Drug Administration has said you cannot give a racemate to a patient unless you are confident that the inactive enantiomer causes no harm. How easy is it to prove that something causes no harm?
No.
It's essentially impossible. Essentially impossible. Not completely impossible, but essentially impossible, right? And so you have a situation where most of the drugs you take today are expensive in part because a scientist has to sit there, separate these enantiomers out, or figure out how to only make the one version of it through chemistry, and that's complicated. That's very, very complicated. Okay? Let me give you a couple of examples of chiral drugs that you all have probably taken. How many people know of methamphetamine? Right? I'm not saying you've taken it, right? But you know of methamphetamine. But actually, everybody in this room has probably taken methamphetamine. If you have ever taken a Vicks vapor inhaler and gone, oh, I can breathe so much better, you have inhaled methamphetamine. But it is the enantiomer that does not cause hallucinations and you to go nuts. Okay? There are two hands to methamphetamine. The stuff on the street is racemic. And one enantiomer of it will cause you to get high and is illicit and is illegal and cause your teeth to rot out and all that kind of stuff. The other enantiomer, if you can separate that out, actually helps open up the airways and causes no psychological issues whatsoever. But it is connected exactly the same. It has the same number of carbons, hydrogens, and nitrogens. They're just like our hands. One is non-superimposable on the other. That's because that one that we're inhaling to open up our airways interacts with different biological molecules than the other one. Okay? And that's pretty cool, right? So, if you've ever used a Vicks Vapor inhaler in the United States, you have used methamphetamine. It will say on the back of the package contains LEV, methamphetamine, LEV meaning the left-handed version. And it's absolutely pure. And they have to make sure that it's absolutely pure because if it's got the other enantiomer in it, you're doing drugs. Okay? And so you can't do that. So scientists have to figure that all out. Now let's talk about one that may be a little more. Has anybody ever taken naproxen sodium, aka Aleve? Okay, well, a lot of people do. Some probably have at some point. Naproxen sodium is an anti-inflammatory, right? You take it when you get a fever, when your joints hurt, whatever. A lot of people take it. And it turns out that one enantiomer of naproxen sodium cures your ailments. Do you know what the other enantiomer does? It kills your liver. It is a potent, and I mean potent, liver toxin. You will die if you take the other enantiomer. So when you go over the counter and you get naproxen sodium and you take it, what are you trusting? You are trusting that the chemist who made that knew how to make only the R enantiomer, which is, I think it's the R enantiomer. Don't worry about it, the right-handed version, if you will, and put it in the pill. So some chemist somewhere had to figure out how to make that, and only that, in a way that they could package it in a pill and not cause any health problems. And so chirality, I'm very passionate about chirality, right? But this all came about because Louis Pasteur was noticing that tartaric acid formed two different crystals that looked like mirror images of one another that were non-superimposable. He did all this under a microscope. And it turns out that when he separated these crystals, they have like, ones that look like this in one bucket, one that look like that in another bucket. He noticed that they would rotate light differently, plain polarized light. You'll learn about that in organic chemistry. It's a really cool topic. Okay? But it's kind of esoteric when you first see it. Oh, it rotates flame polarized light in opposite directions, so what? Well, then we started to realize that so what is how those molecules interact with biological systems is different, and it can be as different as an illicit drug and something that helps you breathe better to something that cures your headache or kills you. That's pretty powerful stuff. And so as you all think about going into the medical profession or the pharmacy profession, it's important that you understand that. Okay, that there's a lot that goes into making these drugs, and that the biology of it is really related in chemistry. So, really cool topic in my opinion. And so, enjoy talking about it anytime I can. Let me see, where do I want to go now? I need to go to... We need to talk about CVs and resumes. Now, how many of you have a CV or a resume already going? Okay, anybody turned theirs in yet? Not yet, okay, that's fine, you still got some time, okay? So, how do you all keep your resume or your CV? What do you have it on right now? Word document, PDF. Yeah, I'm pretty fortunate, and I got this thing called Faculty Success that keeps my resume for me in digital format. So I can generate all of my CVs very, very easily. And I'm going to show you that you all don't have this, that's okay. But we're going to talk about the different components of a CV by looking at mine. So, what is the difference between a resume and a CV?
Specifics.
Specifics? What do you mean by that?
Like the CV would be more specific and have more details than a resume.
Okay.
Didn't you say like the only difference is the length between the two?
The length is different, that's certainly true.
On a CV, you go more to like your educational background.
Okay. True. Let's see, where is my, oh, I got to do this under activities, that's right. So I've got a bunch of different CVs out there. I can run the report. This will generate a lot of CVs for me. Okay. Now, I am not suggesting that this is the way that each and every one of you have to submit your CV, okay? But I do think you all need to take some pointers from it. So let me zoom that in a little bit so it's clearer. All right. So, what do you immediately notice about my CV?
It has your contact information at the top.
Yep, has my contact information at the top. All my information is up here. Notice what's not there. What's not there?
Picture.
I don't have a picture, okay? Now, I will not count off if you put a picture, but it turns out that some people believe they need to include their picture. Some people have a strong preference not to include their picture. I think it depends on what you're going for. I would highly recommend you from a professional point of view not to include a picture on your CV. Why would I make that statement? Pardon?
I know for some people, or like the people that are receiving the resume, they don't want to have like a bias.
A bias.
There's a specific word for it.
Yeah, it's implicit bias.
Implicit, that's it.
Implicit bias. Everybody, by the way, has this.
Yeah.
We do judge things by how they look, right? And we don't want that to come into play. It is most recommended on a professional CV for you not to include a picture. Now, where might that be an exception? You want to go get a job making a movie. I want to know how you look, because that's artistic, that's, trying to find something, you're trying to do a modeling thing, but that's not us. We're scientists, right? So we're going to ignore that. You'll notice that I do not have my home information up here. Okay? You all are not employed anywhere else. It would be hard for you not to have you'll notice that is not my cell phone number. That is my professional number, right? You'll notice that I'm using my professional email address. I'm not using my Hotmail or my Gmail or my Yahoo or my whatever else we've got today. I am using that. You will also know that I am not giving my Twitter X. I am not giving my TikTok. I am not giving my Facebook, whatever.
Can we give up LinkedIn profile?
LinkedIn is a professional version of social media. That is perfectly acceptable. Okay? And so this brings me to the topic of discussion about our social media profiles. How many of you, and I don't want to see hands, this is rhetorical. How many of you have a social media presence that you would not be willing to show your grandmother? If you're not willing to show it to your grandma, you don't want to show it to a potential employer. Okay? Now, you all have a social media preference, some more than others. I get it. What do you think happens if you all were applying to a job in my shop right now, over in the International Center? What do you think would be one of the first things I'm going to do? I'm going to do a little research on you. You all are sharing way too much from a professional point of view. Okay? Is that okay for me to do? It is absolutely okay for me to do. You have put it in the public domain. It is fair game. It is fair game. And I have an office to run, and I have an office with a mission, and I have an office that has to maintain a certain composure. And if you're counter to that composure, that's going to be a problem, right? But wait a second. What about free speech? You have free speech. You don't have free speech without consequences. Right? So what does that mean for you now? I am very glad I was not born when you all were born, because back in my day, if we had, right? The only thing I really had to worry about was Polaroid cameras. Somebody having a Polaroid of something going on, right? You all need to start thinking about cleaning up your social media presence. When you all apply to graduate school, when you all apply to medical school, when you all apply to X, Y, or Z, they are going to see if they can find anything on social media. Okay? It is in your best interest to start cleaning that up. You have the right to do whatever you want. But again, rights come with consequences and responsibilities. Okay? And people have expectations. Okay? So I would not discourage you from being on social media at all. I would just caution you to be careful about what you post. People will forgive you for your high school posts that might outlive their usefulness. People will not forgive the post that you posted a year before you applied for a job. People can sit there and go, oh, well, that was a party in high school. Yeah, we did. Oh, this was while they were senior putting together their CV and getting ready to apply for a job. My point being is that your social media presence needs to be professional. I would keep your LinkedIn extremely professional. Definitely include your LinkedIn, because if you include the LinkedIn, I'm just not very active on LinkedIn. I've got a job. So, but, you know, point them in that direction first. Keep it professional, okay? But I would definitely go through your social media and start keeping it. You can post things about things that you find interesting, things that you find helpful. You can talk a little politics, but don't go crazy with it, okay? Nobody is saying that you can't talk about things, but be careful about what you post, because your posts will outlive even your opinions. Things that you think today and you post about, 4 years from now you might go, that was silly, or I don't believe that anymore, and yet it lives on. Okay, so keep that in mind. Notice what I have after that. I have professional positions. Will this be what you all have first? What will you all have first?
Education.
Education. And why is mine different from what I'm expecting for you?
For college students.
Because you are college students and I have gone beyond that. That just means I'm old, all right? But it's true, right? Does that mean you don't need to include your work experience? Not at all. I would include your work experience. It shows your motivation. I would not put it at the top because chances are most of you right now have work experience that is not necessarily academic in nature, right? Many of you have had part-time jobs doing this, that, and the other. It shows your willingness to work, shows your drive, your desires, may even show some entrepreneurial activity. But, you know, you haven't been a CEO somewhere. You haven't gotten your PhD yet, those things. And so, you know, I would move your work experience more towards the end of your CV resume at this point. Okay, your CV is a living document. It will change with time. And in fact, if I go into that system and I change the date range, you would see a very different CV from me. I can do it where it's everything I've ever done, or things that only in the last year, which is what I have here just for brevity, right? So, you'll have your job information, work experience, you'll include dates. Okay, people want to know, well, okay, you had a job, but how long did you work at that job? Why is that important? To see your commitment. People who are going to hire you or who are going to give you a scholarship or whatever want to know, are you a committed person to something? And if they go, well, they had a job there for a week, they had a job there for 2 weeks, they had a job there for, unless you can explain it as this was all temporary work, right? But if it's, I worked at Wendy's for 2 days, right? And then if it really was a 2-day job, you need to put out there, this was a temporary job to do X, Y, and Z. But if I was looking at that, I went, they worked at Wendy's for 2 days, and then they worked at Walmart for 3 days. This person gets a job and then they quit. Do I want to hire somebody like that or give somebody a scholarship? Probably not, right? So again, if you have length, right, is very, very important, right? Education. How are you all going to list your education? What is not on my education that should be on yours? High school. Do you think anybody cares about my high school education now? No, so I take it off. Do people care about your high school education? Absolutely. You will get to a point in your career, I promise you, where the high school education will drop off. Okay? I still list some things from high school in my awards area that I'm not going to show you today, because I went to Boys State, which was a selective thing. Okay, I received some pretty prestigious scholarships. I want that to still be known, because guess what? A prospective employee or somebody that I'm submitting a grant to or whatever, and they go, oh, they were a Boys State person. Well, I was a Boys State person. Does it matter? You bet it matters, right? It does matter. If you went to Girls State, whatever, right? But there are some of those things that you will do in high school that still will have meaning later in your life. Now, does it matter that I was, you know, in the Chem Club? Right? I mean, I don't include that anymore. But you'll notice, I include starting with my most recent degree and work backwards. Do not do it the other way around. Now, there's a debate about that, but I always start with the most important first in a CV format, okay? My highest degree is my most important degree for the things that I do, okay? And so you would include that information like that, okay? So how would you list your first education entry? Your bachelor's degree, and how would you list that on there? You would list it as in progress somehow, right? You were at the University of Southern Mississippi studying chemistry, biochemistry, you know, whatever your degree title is. You would put the start date, and then you could put anticipated graduation of, you can do that, okay? That's perfectly fine. Then you would put your high school information. Should you put your GPA on here?
If we
Which
have,
GPA?
If you have it, okay. What?
Your college GPA or your high school GPA?
Either.
If it's good, then.
If it's good, then why not?
Yeah.
Okay, if it's good, why not? I have no objection to you all including your GPA information, okay? What I will tell you is that most of the time, in anything professional, they're gonna ask you for your transcript. That information is going to be there if you make it past the first round. What I would suggest that you do is you can list it a couple ways. You can do cumulative GPA, or you can do degree GPA. Okay, is there a difference? Absolutely there's a difference. Your cumulative is everything you've taken. Your major GPA is just for your chemistry courses, right? Be clear about what GPA you list if it is, right? Most people list their cumulative, because most people that put it on there typically have a really good GPA, right? But you just say cumulative GPA equals, and then do you need to list the scale? You do need to list the scale, especially for your high school GPA, right? Because is a 4.0 GPA the same at every high school? Not at all. Some high schools are on a 5-point scale, right? If you were homeschooled, what do? You know, you're probably not going to list your GPA. You're probably going to list, you know, other pieces that when you received your diploma, et cetera. If there were any kind of awards you got as part of a homeschooled organization, you would want to list that kind of information as well. You'll notice on mine that I've got this thing called licensures and certifications. You will not include that. You will certainly not include teaching experience. You'll notice that I have faculty development activities attended. This could be organizations that you all are involved in. You're definitely going to want to include that information now. You're going to want to include any kind of research activity that you've been involved in. You're going to want to have a section for any presentations that you might have done. That can include high school presentations, college presentations. What do I mean here? Do I mean you got up in front of a class and gave a presentation? No, I'm talking about you're part of an organization and you went to a conference and you gave a presentation. That could be an academic thing, like I just got back from doing something at the American Chemical Society, or it could mean, doing something more along the lines of with my maybe Greek life or whatever, where you went to a conference. But usually you're going to be talking about things done at conferences or competitions here. Okay. Notice I have service. Okay. What would you all include for service?
Like volunteer work?
Volunteer work. That's probably what you're going to call it at this point, right? So if you volunteered for the Red Cross, if you volunteered for Boy Scouts, Girl Scouts, or Scouts, whatever we call them now, if you do anything with your church, you can definitely include that kind of information here, okay? Whatever it is that you find important. It's important that you include the stuff that you do outside of employment. People want to know, were you involved? Were you helping the community? This is extraordinarily important if you're wanting to go to medical school. You can have a 4.0 GPA, you can have a great MCAT score, and if you haven't done anything else, you will not get into medical school. Medical school is so competitive by design of the AMA, I'm just going to say it out loud, there are more people who are capable of being doctors than there are slots. And somehow you have to distinguish yourself from the competition. I have seen people that did not have a perfect 4.0 and a perfect MCAT get into medical school, and I've seen people with essentially a perfect MCAT and a very high GPA didn't even get an interview. And it usually comes down to, what else were you doing in the community? They'll give you a little bit of a break on the GPA and a little bit of a break on the MCAT when they go, well, of course, they were spending some time out helping people in the clinic. They were out helping people that were impoverished or homeless or whatever the case may be, Habitat for Humanity, whatever your activities were. And they did all of this and had a 3.8 GPA and a really good MCAT score. That's the kind of person we want to be a doctor. Okay? Those are the kinds of things that they'll do. So you're going to be thinking about that in terms of volunteer work. Okay? What else might you include, this is clearly not a complete CV, but you all are really gonna have a resume at this point. What else might you include?
References.
References, that's a good thing to do, if and only if what? If you have them, is that what you said? Okay.
Can you just put like references and then put available upon request?
You can do that. You can do that. What you do not want to do is say, here are my references, and never tell your references you're using them as a reference. Right? If you all listed me as a reference, which is fine, come talk to me first. Right? If somebody calls me and they say, so-and-so put you down as a reference, and I go, who? How do you think that's going to go over? Good? Not so good, right? Talk to your references if you're going to list references. Okay? If you have to put something together quickly, put available upon request, and that gives you some time then to go talk to them. You want to make sure that you do not want to list somebody as a reference who's not willing to give you a good reference. I've hired a lot of people since I've been here. It's rare, but I have had occasions when I call a reference and they go, I wouldn't recommend that person. And I'm like, why did this person put this person down as a reference? I don't want to hire that person. Right? Would you? Would you want to hire that person? I don't think so. Right? So keep that in mind as well. What else might you include?
Skills.
Skills. Okay. You will probably include skills on a resume, but not necessarily a CV, because the CV is going to be a lot. Eventually, your skills will wean their way off of your resume as it becomes a CV. Okay, because there's certain skills that are just kind of assumed to be there, as you go on. All right, we are near the end. What day is this due?
Friday.
Friday. Is everybody clear? I do not need a 10-pager, but I need something that looks professional. Notice I did not use fancy fonts. I did not use funky colors. Keep it professional. You can always add flair to it if the cause is needed, but for professional things, do not. On your cards, put your name, your ID number, turn it in on your way out. Have a great Halloween, and I will see you all next week where we will talk about some non-traditional career paths in chemistry and other things.